Hello, welcome back to my YouTube channel. For those who are here to subscribe, please subscribe, like, and share. In today's tutorial, I'm going to be teaching us data structure in Python. So let's dive into the tutorial properly. Okay, data structure is a way of organizing data in a way that it can be accessed easily and used efficiently. Have a look. Imagine you are faced with a problem of arranging some fruit inside the basket. For example, you have some bananas, oranges, and apple to be arranged inside the basket. You can actually put everything together like this, or you can arrange it as in some of the bananas together, some of the oranges together, and some of the apples together like this. So when you look at these two, when it comes to accessing them later, we realize that the ones that is well organized can easily be used. Okay, let's look at it programmatically. Okay, in a situation where you have apples, orange, and banana, and you can actually store them at random, making use of a list. List is one of the data structures, but this does not have a particular pattern. You just put all the elements inside the list, and they can also be retrieved in different order, which is not as efficient, and it takes a lot of memory in the computer. You can also store it making use of a dictionary. When you make use of a dictionary, you can see that apples are stored together along with a key. Bananas are stored together using another key, banana. Orange are stored together using a key, orange. This is more efficient and easy to use. At the same time, it's the memory. It uses the memory of a computer efficiently. There are two types of data structure. We have the inbuilt data structure, and you have the user-defined data structure. The built-in data structure include list, dictionary, tuple, set. It's called built-in data structure because this type of data structure comes with Python libraries. So you you just make call the library and make use of them. But the user-defined data structure, you'll be the one to create the structure yourself, depending on the need, depending on the situation, and the condition that requires them. Okay. Let me explain with some examples. This is a list. A list is created using a square bracket. So this list has four elements in it. So these elements can be of different data types. A list does not have a restriction on the type of data that is being stored in it. So, for example, this is an integer, this is a float, this is a string, and everything can be stored in a list. So, I'm going to look through this list and display the data types of these elements. So, if you notice, this type of bracket is called a square bracket, which is used to create a list. So let me run the program. So and it displays the data types for each of the elements. In addition, elements stored in a list can be accessed through their index. For example, in this list, we have four elements, and the index starts from zero. So this is 0, 1, 2, 3. So if I want to access the first element, all I need to do is um, print the variable name and put the index number in a square bracket. The same way, if I want to access the third element, all I need to do is the fourth element, all I need to do is put the variable name and put the index number inside the square bracket. So let's run this program and see. So you can see that the element in index 0 is 4, which is this, and element in index 3 is Python, which is this. Okay, let's take it a step further. This is a list with 4 items in it. I can also add a new item to this list by using a function called append. So append will add a new item to the list. That's from the back here. So I have items.append, and what I want to add to it is a string and new. So let me run it, the program, and see. That's added it. So let me print to see how it works. Let me print. So I've added it to it. Then I want to print, look through the items now and see if that's been printed. So all I need to do is run it the second time. I'm gonna save this. Then I run the program again. As you can see, it has added new to this list. Let's take it a step further by looking at insert function. So the insert function helps to add a new element to the list, but you need to specify the index, the exact point you want it to add the new element. So you need to specify first the index, then specify the element you want to add to it. So in this now, I want to insert 9 into index 2. So it will be 4, 6, 2, then 5.5. So let me run this and see. Let me run this. So 4, 6, 9, 5.5, because I've added it to index 2. And I also add another thing apart from integer. I also say okay, in index 4, I want to add the string there. Program. So let me make it index 5. So let me save it and let me run it again. And it's adding all these elements to it at runtime. So as you are adding the element, you notice that the leaks keep growing as it keeps. So let's look at the pop function. So pop function helps us to remove element from the list. So and it uses this syntax. So all we need to do is specify the index of the element we want to remove. So for example, if I run if I want to remove 5.5, 5.5 is on index 3. So all I need to do is type items dot pub, then put index 3. So it will remove 5.5 from the list. So let me run it and see. So notice 5.5 is gone. So anytime you want to remove element from the list, you make use of a pop function alongside with the index of that element. At this point, let's look at the use of dictionary. Dictionary is another type of data structure. It uh, it is more organized or well organized than a list. Let's have a look at this example. This is fruit, which is a variable. So a dictionary makes use of a curly bracket. This this is a key, and these are the values. So for you to create a dictionary, you need to have a curly bracket, you need to have a key, and you need to not have the values. So in this situation, you see that there are two um, apples here, two bananas, and one orange. So, but this is grouped together in a way that all the values for apple are grouped together and they are assigned to a key, which is apple. So, with the use of this key, you can access all the values attached to it. With the use of this key, you can access all the values attached to key banana. The same thing goes for orange. So let's print out this dictionary and see how it looks. So print fruit. So let's run the program. Let's see how it appears. So when you look at it from here, you see that this is apple as a key, and these are the values. So with the use of this key, you can access all the values that are assigned to it. So it makes it more organized and more memory efficient compared to a list. So you can also, so let's take it a step further. Let's print the values in banana. So to print this, you write print fruit, which is the name of the variable. Then you use a square bracket and you put the key, which is banana. So save it and run it. So this is the name of the variable. So for you to access any of these values, you make use of the variable alongside with the key. The variable alongside with the key. Then you'll be able to access the values. Save it and let's run it. So these are the values in banana. So if I want to access orange, all I need to do is fruits and put orange here. Okay, let's take it a step further. If you want to add a new value to the dictionary, for example, if you want to add a new value orange to an existing dictionary, all you need to do is to state the value, the variable, the key, and use append function, then the value you want to add to it. So let's run this. So we now have two values of oranges. So you can also add another one to it. For example, save it. So we should have three values of orange. So you save, you run it, then you have this value. You can do the same for banana. All you need to do is to state the variable, the key, and the value you want to append to it. Okay, at this point, let's look at how to remove some values. So you already have dictionary, and inside the dictionary you have apple. You have two values of apple. So you want to remove one out of it. So you create a loop and you write it this way. If apple is this and this, then you make use of the remove function to remove one apple from this. So what this loop is simply doing is to check if we have any key which is apple, that's from this, and to check if it has a value which is apple. This is checking for the value apple. So if we have any if this condition is satisfied, then it will remove one of these values from the dictionary. So let's run it and see the outcome. So run this way. So if you look at it, you see that we now have only one apple in the dictionary. So if I want to remove another one, all I need to do is copy this and paste and run it again. So if I want to remove orange, all I need to do is and run it again. So if I want to remove orange, all I need to do is modify this condition to fit in for orange. So instead of apple, I will have orange in this. I will have orange here. I will have orange here. Then I will remove orange from this condition. Another data structure we are going to consider is the tuple. The tuple is similar to a list, just that the tuple is immutable. Immutable means that once it has been created, it cannot be changed. So most time we make use of a tuple when we want to create constants or values that will not change all through the program execution. So immutable uh, also means read only. So once you create it, you cannot modify. Um, you cannot modify a tuple. The only thing is you can create another one and give it another variable name. So in case you want to make any changes. But the advantage of a tuple is that it doesn't change during execution and is faster than a list. So most times it's ideal for performance critical codes. A tuple is used when you are dealing with the location of a particular place, dealing with the longitude and latitude. It's also used when you're dealing with a color, maybe red, blue, green, because these color codes are constant for a particular color. So those are areas where you make use of a tuple. Anytime you're dealing with values that doesn't change. Another data structure we'll consider is set. It's you declare a set making use of a curly bracket, and a set only keeps unique values or unique elements. So you make use of a set whenever you want to return only unique elements or store only unique elements. So if you have duplicates within the records, a set will remove all the duplicates and only return a unique element. So we'll make use of. Thank you for watching up to this point. Everything we have discussed, I would like you to practice from your own end. And in case you have any challenge, uh, leave it in the comments, and I will help you out. Please like, subscribe, and share so that we can reach out to more audience. See you in the next video. Bye.